Hey guys, and welcome to this video on graphing a new type of linear equation. So let's get right into it. In our first example, we've got y equals 3 minus 2/5 times the quantity of x plus 4. Now, we're kind of used to graphing things similar to this, but maybe something like y equals 3 minus just 2/5 x. And I hope that we know what this graph looks like. For instance, I think it's got a y-intercept of 3. And if we were to make a table of values, on that table of values, if we were to have an x value of 0, we would have a y value of 3. And of course on our graph, that's going to show up right on our y-axis, right there at the point 0, 3. And this slope of negative 2/5, well, that implies that, give me a second here, right, that's our change in y over our change in x. Right, that was our definition of slope. And it means that from this kind of starting point, from our y-intercept, for a 5-unit increase in x, we will experience a 2-unit decrease in y. So every 5 units that x increases, so from 0 to 5, from 5 to 10, we will experience a 2-unit decrease in y. And of course, vice versa. If we have a 5-unit decrease in x, we will have a 2-unit increase in y. And so we can go ahead and graph this, no problem. If you give me a moment, I will do just that. So 1, 2, 3, 4 points we'll draw. So here we'll draw the point 5, 1. Here we'll draw the point 10, negative 1. And negative 5, 5. And negative 10, positive 7. All right, not so bad. But my question is now, what happens when we change our equation ever so slightly? So that instead of just 2/5 times x, or negative 2/5 times just x, what if we have negative 2/5 times the quantity of x plus 4? So we've just kind of replaced x with an x plus 4. Well, let's see what happens now. And what I want to do to motivate our strategy is to consider, back in the day, an equation that we have graphed. Something like this. And I'm going to do this over here, and then we'll erase it to actually do that problem later. Something like y equals 3 plus the quantity x plus 4 squared. And there's definitely some similarities between this equation right here and this one right here, right? We've got a y equals 3. Here's its subtraction, here's addition. We have an x plus 4 in parentheses. Of course, this one is being squared, and this one is not. But the strategy we use here is going to be similar to the strategy that we're going to use here as well. And here, I hope that we remember what this graph is going to look like. In general, it's going to be a U-shaped graph. This is going to be a parabola. And our strategy right now for graphing this equation, perhaps you already know what it looks like, which is great. But oftentimes, we would make a table of values, an XY table, an input-output, or independent variable table. And what we're used to doing is oftentimes when we first started, we would center our x values at 0 and kind of branch out in either direction from there. 1, -1, 2, -2, etc., etc. However, in this example, if x is 0, right, 0 plus 4 is 4. 4 squared is 16 plus 3. Holy cow, we're at 0, 16. I mean, we're already off the graph. So with this example right here, centering our x values at 0 is not really going to be very helpful. So we're going to need to find a different strategy here. But what we actually want to do is we want to center our x values in such a way that this thing that's being squared, that this thing is going to start at 0. We want to center this thing at 0, x plus 4 that is. So I think we want to actually start our x values at negative 4. Because, check it out, negative 4 plus 4 is 0. 0 squared is 0. That's fantastic. Of course, our y value would then be 3. And this is going to be a really, really, really important point on our parabola. And of course, it is intimately related to the fact that we've got an x plus 4 quantity squared, and then we've got a y equals 3 plus, right? We got this 4 and negative 4, these 3's. Of course, there's another connection we're going to make soon, which is, of course, this original equation could have been written as y minus 3 equals x plus 4 quantity squared. Okay, but even so, now we want to center our x values around negative 4. So now we'll, negative 3 and negative 2, negative 3 and negative 5. Negative 2 and negative 6, negative 1 and negative 7. Right, we're just branching out from that x value of negative 4. I'm going to do some calculations quickly in my head, but you could do them just as easily. So we're going to have 4 and a 4 and a 7 and a 7. And a 12, and a 12. So it's going to go off the graph, but alas, what can you do? And so I'm going to draw some of these points on our graph. 1, 2, 3, 4, 5 at least we'll be able to get. So -4, comma +3, that is a super important point. We've got -3, comma 4. We've got -5, comma 4. We've got -2, comma 7. And then we've got -1. Excuse me, -6, comma 7, pardon me. And you know, we could do 2 more just to kind of, this is going to be a little bit of eyeballing, but it's going to look something like this. And we've got our parabola. Pretty groovy. And right, this parabola is going to be centered right around, it's symmetric right around that x value of -4. And so what we're going to do is we're going to do the exact same strategy of centering our x values that we used here, but in problems like this. So I'm going to erase all this work that we did here. But what we're going to want to do is we're going to want to center our x values not at 0 here, but at -4. And so let's see what happens. So bye-bye, bye, bye-bye, adios. Okay, check it out. And of course, I mean, check it out. You know, most people like to go ahead and insert an x value of 0 to begin, right? They want to find our y-intercept, but you know, 0 plus 4 is 4. -2/5 times 4 is -8/5. And 3 is 15/5, so 15/5 minus 8/5 is 7/5. Who wants to graph 7/5 on their graph? I don't want to graph that. So what we're going to do here is we're going to start our table of values with an x value of 4. So x, y, let us center our x values at 4. And of course, if, excuse me, -4, pardon. So if our x value is -4, right, that makes this thing right here 0. So -4 plus 4 is 0, -2/5 times 0 is 0, so y would be equal to 3. And again, this is going to be a really, really important point on our graph. -4, comma 3. This is going to be a line. It's not going to be a U, but this is still a very important point. And also want to kind of make the note that we could have originally written this as y minus 3 equals -2/5 times the quantity of x plus 4. Because this is going to help us find some patterns later as well, right? And of course, it's no coincidence that the point -4, comma 3 is on our graph. And now the question is, well, what kind of x values should we use? Well, I still think that our slope, our rate of change is -2/5, right? We're multiplying -2/5 times this quantity. And as this quantity changes, so will y. And so my claim is that our slope is exactly the same as it was before. So that means that our change in y over change in x is going to be -2/5. So a 5-unit increase in x should result in a 2-unit decrease in y. So if we were to increase x by 5 units, so going from -4 to 1, we should have a 2-unit decrease in y. If x were to go up by 5 more, we should have a 2-unit decrease in y, and of course vice versa. If x were to decrease by 5, y would increase by 2. And so now we've got a whole bunch of points on our hands that we can use to graph. I'm going to do one of them in green, and I'm going to do 1, 2, 3 of them in black. Of course, I want to label my axes. And so let's see, we've got a really important point, -4, comma 3, ding, 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 which is awesome. Then we've got 1, comma 1. We've got 6, comma -1. And we've got -9, comma 5. Looking good to me. Let's see if I can draw a nice line here. Nailed it. Can I get that guy? Can I get him over here? Yes. Ba-boom. Might be a little rough sketch, but alas, what can you do? Oh, phenomenal. And so we have now accurately sketched that graph. And check it out. It's no surprise that if you look at this equation, yes, if we just start with an x value of -4, we're definitely going to get a y value of 3, right? This becomes 0, all of this becomes 0, y becomes 3. And so boom, you can immediately find a free point on this graph, -4, comma 3, which you can also use using this equation. And then the slope remains the same, so we can use that slope to find more points on our graph, no problem. And that's the general strategy for graphing these kinds. Okay, I'm going to skip this one because we got all this beautiful work here. Let's do one more example, and then that's going to be it for this video. So making our way down, y minus 4 equals -2/3 times the quantity x plus 1. Once again, if you try an x value of 0, you're not going to get a nice y value. So your y-intercept is not somewhere you'd want to start. But my claim is, check this out, we have an x plus 1 here. If we start with an x value of -1, so if we center our x values at -1, that's what's actually going to be the most helpful. Because check it out, -1 plus 1 is 0, right? And then this whole side of the equation becomes 0. So all we need to do is find a y value to make this 0. Boom, y equals 4. I mean, that was fast. I mean, this is going to be our kind of mega important point right here. -1, 4. Let's go ahead and graph that too. Let's draw as much attention to it as we possibly can. Boom, there it is. And note to self, sometimes we're going to see this equation given in this form. Another form we often see it in is y equals 4 minus 2/3 times the quantity x plus 1. And I actually really like this form a lot more, but it's important to be familiar with both of these. I just added 4 to both sides of this equation. And so from here we say, okay, we know what the slope is. The slope of this line, it's going to be a line, is -2/3. And so if the slope is -2/3, that means that our change in y over change in x is going to be -2/3, excuse me. After, we know this 1 point, now we can find so many more. So for a 3-unit increase in x, so from -1 all the way to 2, we should experience a 2-unit decrease in y. For another 3-unit increase in x, a 2-unit decrease in y. And of course, vice versa. For a 3-unit decrease in x, we should have a 2-unit increase in y. And so now we've got all these extra points that we can graph. Let's go 1, 2, and 3. So we've got 2, 2. We've got 5, 0. We've got -4, 6. And I'll just kind of call it there. Here, let me rein in this nice line for us. Ba-boom. Oop, that was no good at all. And I know this is a bit inaccurate, but in the interest of time, I'm just going to leave it as is. And so we can see right here from this graph that, oh, check it out. This equation, its graph is definitely going to contain the point -1, 4. Right? You're going to get 0 equals 0, which is great. I kind of consider that like the starting point of this graph. And then it's got a slope of -2/3, so we can use that to graph other points really quickly. I also like this form of the equation because I also think of like this 4, it's similar to the y-intercept. It's not the y-intercept, but it's kind of like the starting point of our line. Y starts at 4. Not when x equals 0, but when x equals -1. And then we can proceed on from there. So I hope that this strategy will work for you as you try to graph some other similar types of equations.